let's move on to the next question. Question number 10. For which one of the following curves the tangents at right angles cannot be drawn from any point? First curve, x square by 9 plus y square by 4 is equal to 1. Second curve, x square by 9 minus y square by 4 is equal to 1. Third curve, x square by 4 plus y square by 9 is equal to 1. And fourth curve, x square by 4 minus y square by 9 is equal to 1. We know that perpendicular tangents can be drawn only from a point on the director circle of the either the hyperbola or the ellipse. So, perpendicular tangents can be drawn from points on director circle. Whether it is for circle or ellipse or hyperbola, perpendicular tangents can be drawn from the director circle. For x square plus y square equal to a square, that is circle, the corresponding director circle is x square plus y square is equal to 2a square. That will be that is the radius of that director circle will be root 2 times the radius of the given circle. And when it comes to x square by a square plus y square by b square equal to 1, that is the ellipse. For the ellipse, the director circle is given by x square plus y square is equal to a square plus b square. And for the hyperbola, x square by a square minus y square by b square is equal to 1. Hyperbola, the director circle is given by x square plus y square is equal to a square minus b square. Now this equation will yield points, real points. It will be a real circle provided a square must be greater than or equal to b square. So if a square were to be less than b square, for a hyperbola, we will not be able to draw perpendicular tangents to such a hyperbola. So if you look at the options, the first option says it's an ellipse. For an ellipse, there is no problem of drawing perpendicular tangents from any point. I mean, that is from points on the director circle, we can draw tangents, perpendicular tangents. So first option is okay. I mean, first option cannot be chosen in the sense that we can draw perpendicular tangents to the ellipse. Coming to the second one is an hyperbola with a square greater than b square, so there is no problem. Third one, it's again an ellipse. We will be able to draw perpendicular tangents from points on the director circle, that is x square plus y square is equal to 13. And for the fourth option, we observe that a square is less than b square, therefore there will not be any real director circle. So hence the option x square by 4 minus y square by 9, if you look at, equal to 1. The director circle, if there have been x square plus y square equal to 4 minus 9, which is impossible. This is not going to be a real circle, not a real circle. So which means that not real. Hence we will not be able to draw perpendicular tangents, or there will not be a director circle for the hyperbola x square by 4 minus y square by 9 is equal to 1. So hence the option 4 is the right option, because for that curve we will not be able to draw perpendicular tangents from any point. Option 4 is the right option. Let's move to the next question. The question, it goes like this: the product of the perpendiculars from the foci on any tangent to the hyperbola x square by a square minus y square by b square equal to 1 is 1. First option b square, second option a square, third option minus b square, and fourth option 2b square. Now actually this is the result, and we'll prove that result. Y equal to mx plus root over a square m square minus b square is a tangent with slope m for the hyperbola x square by a square minus y square by b square is equal to 1. The foci, we know that the foci are plus and minus AE comma 0. The foci here, E being the eccentricity, b square is equal to a square into e square minus 1. We know all this. Now, the perpendicular distance from AE comma 0. Let us say the first focus is AE comma 0. This line we'll rewrite in the form of mx minus y plus root over a square m square plus b square minus b square is equal to 0. So, I want the perpendicular distance from AE comma 0 to this. So, P1 is equal to m into AE plus root over a square m square minus b square divided by root 1 plus m square. Similarly, the distance, perpendicular distance from the second focus will be m into minus AE plus root over a square m square minus b square by root 1 plus m square. Now, what about P1 into P2? So, P1 into P2 will be equal to, from here, P1 into P2 is equal to a square m square minus b square minus m square a square e square, x plus y into x minus y kind. So, divided by 1 plus m square. We can even rewrite this in the form of m square into a square e square minus a square. I'm multiplying the entire thing by minus 1 plus b square divided by 1 plus m square. I took a minus 1 common, and this has become minus term has become plus, and this term would have been made minus. So, what do you have now? What is a square e square minus a square? That is b square. So, we can write this in the form of m square plus 1 into b square divided by m square plus 1 and a modulus. So, P1 into P2 is therefore equal to this m square plus 1 and m square plus 1 cancels, and we have it to be equal to b square. So, product of the perpendicular distances from the two foci to any tangent is a constant, and that is equal to square of the semi-conjugate axis. Here, what is the semi-conjugate axis length? B is the semi-conjugate axis length. What did you find P1 into P2 to be? B square. So, that's what. So, it's an important observation and has to be borne in mind. So, option 1 is the right answer. Let us move to the next question, question number 12. The eccentricity of the conjugate of the hyperbola for the given hyperbola 4x square minus 9y square minus 8x minus 32 is equal to 0 is, first option root 13 by 3, second option 5 by 3, third option 5 by 4, fourth option root 13 by 2. Now, if h is a hyperbola and if its eccentricity is even, its conjugate h dash, let us say conjugate, will have their transverse and conjugate axis reversed, and suppose its eccentricity is E2, there is a relation 1 by E1 square plus 1 by E2 square is equal to 1, that is 1 upon the eccentricity of the given square of the eccentricity of the given hyperbola plus 1 upon the square of the eccentricity of the conjugate hyperbola is equal to 1. So we can use this relation. We are given the hyperbola, given the hyperbola. For the conjugate, let me assume that the eccentricity is E2 and we will find out the eccentricity using this equation. Right. Now, what is the hyperbola given to us? 4x square minus 8x plus 9y square minus 32 is equal to 0. Let us write this in the standard form. Let's write this in the standard form. We'll take out a 4 common, we'll have it as x square minus 2x. We need to complete the perfect square here, so we need to add a 1. That means we're actually adding a 4 here. So we will compensate that by adding a 4 here. Now we have a 9y square. This minus 32 can be brought that side, therefore we have 32. Okay. This is minus 9y square there, minus 9y square. So what do we have? 4 into x minus 1 the whole square minus 9y square is equal to 36. Bringing this into the standard form, we have x minus 1 whole square by 9 minus y square by 4 is equal to 1. Now what is the eccentricity of this? E1, let us say, is the eccentricity of this. That's given by 1 plus b square by a square under root. So what is that? 13 by under root of 13 by 9. Under root of 13 by 9. So what is 1 by E1 square? That's going to be 9 by 13. 9 by 13. We know that 1 by E1 square plus 1 by E2 square is equal to 1. Therefore, 1 by E2 square will be 1 minus 9 by 13. So from here, we know this relation. 1 by E1 square plus 1 by E2 square is equal to 1. 1 by E1 square, we got it to be 9 by 13. So what is E2? The eccentricity of the conjugate hyperbola. So the relation between these two is this. So using that relation, we have 1 minus 9 by 13, that is 4 by 13. And therefore, 1 by E2 square is equal to 4 by 13. E2 is equal to, therefore, root 13 by 2. For the right option is option 4. Option 4 is the right option. Let's move to the next question. Question number 13. The locus of the point e power t plus e power minus t by 2 comma e power t minus of e power minus t by 2 is a hyperbola of eccentricity. First option root 3, second option 3, third option root 2, and fourth option is 2. Now we are given that x coordinate of any point on the hyperbola is e power t plus e power minus t by 2. In fact, this is hyperbolic cos t. And y coordinate is e power t minus of e power minus t by 2, which is hyperbolic sin t. We know that hyperbolic cos square minus hyperbolic sin square is equal to 1. You can even verify here, x square minus y square is equal to 1 here. So this is a rectangular hyperbola, A equal to B. For a rectangular hyperbola, it's a rectangular hyperbola. What is a rectangular hyperbola? A hyperbola where the length of the transverse axis is equal to the length of the conjugate axis. So here we have x square minus y square, x square by 1 minus y square by 1 is equal to 1. So it's a rectangular hyperbola, and the eccentricity is clearly 1 plus 1 by 1 under root, and that is equal to root 2. So eccentricity of a rectangular hyperbola is root 2. So clearly the right option is option 3 is the right option. The ratio between the transverse axis and the conjugate axis of a hyperbola is 5:2. Then E is equal to, first option root 31 by 5, second option root 29 by 5, third option root 33 by 5, fourth option root 29 by 4. So here is the 14th question. Look at this. We are given that the ratio of the transverse axis is to the conjugate axis. What's the length of the transverse axis? 2a. What's the length of the conjugate axis? 2b. That ratio is given to be 5:2. So I can even write it as a:b is 5:2. In other words, b by a is equal to 2 by 5. We know that the eccentricity is given by 1 plus b square by a square under root. So we can use that now. 1 plus 4 by 25 under root, and what is that equal to? It's clearly 29 by 25, root 29 by 5. That's the answer. So root 29 by 5. So that's the answer. So option 2 is the right answer. Okay, let's move to the next question, question number 15. The equations of the latera recta of the hyperbola 5x square minus 4y square minus 30x minus 8y minus 39 is equal to 0 are x equal to 9, comma x equal to minus 3. Second option x equal to 6, comma x equal to 3. Third option x equal to minus 9, comma x equal to 3. Fourth option x equal to minus 6, comma x equal to minus 3. Now let us first write the equation of the hyperbola in the standard form. Let us club all the x terms first. 5x square minus 30x, and then we have a minus 4y square minus 8y minus 8y minus 39 is equal to 0. We observe that this can be brought into the standard form x minus h whole square by a square. We can bring this into the form of some x minus h whole square by a square minus y minus k whole square by b square equal to 1. This kind of a standard form we can bring this into. So to do that, we have to complete a perfect square in the x terms here. So what do? I take out a 5 common here, 5 into x square minus 6x. So in order to make it a perfect square, we need to add a 9 here. So 5 into 9. So 45. On the right hand side, we'll add a 45. Okay. Now a minus 4 can be taken common in these two terms. We'll have y square plus 2y. Y square plus 2y. In order to complete this as a perfect square, we need to have a 4 added up. So minus 4 was introduced here. So I need to add a 4. So minus 4 was introduced. So I need to introduce a minus 4 here. I need to introduce a minus 4 here. But this minus 39, I'll take it that side. So plus 39. So what does it become? 39 minus 4, that is 35 plus 45, that is 80 there. So what we have is 5 into x minus 3 the whole square minus 4 into y plus 1 the whole square is equal to 80. So now it is in the form of x minus 3 whole square by 80 by 5 minus y plus 1 whole square by 80 by 4 is equal to 1. So we have this equation transformed this way: x minus 3 whole square by 16 minus of y plus 1 whole square by 20 is equal to 1. Now this is a hyperbola with the center as 3 comma minus 1. So center is 3 comma minus 1, and we have y equal to minus 1 to be the transverse axis, x equal to 3 is the conjugate axis. So 3 comma minus 1 is the center. This is the line x equal to 3, and this is the line y equal to minus 1. The length of the transverse axis is 8 units because a square is 16. So a will be 4, 2a will be 8 units here. Now we are asked to find out, we are asked to locate the latera recta for this. A latus rectum is going to be a line which is parallel to the conjugate axis and which will be at a distance of AE units from the center. So that is, now what is that AE? What is A for us? A is 4 because a square is 16. A is 4. What is E? Let's find out E. Eccentricity is 1 plus b square by a square under root. So 20 by 16 under root. That makes it 6 by 4, and that is equal to 3 by 2. So eccentricity is 3 by 2. What will be AE? AE value will be 6 units. So 4 into 3 by 2, that will make it 6 units. So this AE is 6 units. This line is x equal to 3. If I move 6 units to the right side, what will be the equation of the line? X equal to 9. Now one more latus rectum I will get by moving AE units this side. That is, okay, so another 6 units to the left here. So when I subtract, I have to subtract now 3 minus 6, that is going to be x equal to minus 3. So x equal to 9 and x equal to minus 3, these are the two latera recta for this hyperbola. So what did we do? We have actually converted this into the standard form x minus h whole square by a square minus y minus k whole square by b square is equal to 1. That got converted this way. A square is 16, b square is 20. So 1 plus b square by a square under root is the eccentricity. A is 4, AE length is equal to 6. We know that the latus rectum, latera recta have to be positioned parallel to the conjugate axis at a distance of AE units from the conjugate axis. What was the conjugate axis here? X minus 3 equated to 0. So from x equal to 3, you move 6 units that side, you get one latus rectum. Move 6 units this side, you get the other latus rectum. So x equal to minus 3 and x equal to 9 are the two latera recta for this hyperbola. Therefore, the right option is option 1 is the right option. Let's move to the next question. Question number 16. The slopes of the common tangents to the parabola y square equal to 24x and the hyperbola 5x square minus y square is equal to 5 are, first option plus or minus 3, second option plus or minus 2, third option plus or minus 6, and fourth option plus or minus 5. Now let's have a look at this. For y square equal to 4ax parabola, a tangent with slope m is y equal to mx plus a by m. For x square by a square minus y square by b square equal to 1 hyperbola, a tangent with slope m is given by y equal to mx plus or minus under root over a square m square minus b square. Okay. Now, if they are to have a common tangent, that means a common m value for which this line has to become a tangent to the hyperbola. So now, what do we have in our problem? Y square is equal to 24x. So a tangent to this will be of the form y equal to mx plus, instead of a, 4a we have 24. So mx plus 6 by m. 4a is 24. So this implies a will be equal to 6 here. A is 6 here. Now coming to the next, the hyperbola. What is the hyperbola given to be? 5x square minus y square is equal to 1. That implies it is x square by 5 actually. So x square by 1 minus y square by 5 is equal to 1. Now in this, what is a square? A square is this and b square is this. So what is the tangent with slope m to this? Y is equal to mx plus root over a square m square, that is m square, 1m square minus b square, that is m5. Now we were asked to say for what values of m they have a common tangent. That is, these two should be identical lines for some value of m. So what should have happened then? 6 by m should have been equal to root over m square minus 5. So common tangent condition, 6 by m should be equal to root over m square minus 5 for common tangent. So that is, if this 2 are to represent the tangent to, common tangent to the hyperbola as well as the parabola. So 6 by m should have been equal to root over m square minus 5, that is 36 by m square is equal to m square minus 5. Now what we'll do is, we'll take m square as some lambda and solve for lambda here, because it is now appearing to be a biquadratic. Let's make it into a quadratic. So what do we have here? So let's move on to solve this equation here. We have 36 by lambda is equal to lambda minus 5. So lambda square minus 5 lambda minus 36 is equal to 0. That gives us lambda minus 9 into lambda plus 4 is equal to 0. Lambda plus 4 cannot be 0 because lambda is m square plus 4 cannot be 0. This is not 0. So lambda has to be 9. That is, m square has to be 9 only. So m square is 9, which implies m has to be plus or minus 3. So the common tangents can have a slope, can have slopes as plus 3 or minus 3, and therefore the right option is option 1 is the right option. Let's move to the next question, question number 17. If 4x minus 3y is equal to root 3 is a tangent to 4x square minus 9y square equal to 1, then the eccentric angle of the point of contact is, first option pi by 4, second option pi by 6, third option pi by 3, and fourth option pi by 2. Let's move on to this. Now x square by a square minus y square by b square equal to 1. Any point on it can be taken in the form of a secant theta comma b tan theta is a point on it, a general point on the hyperbola. Here theta is the eccentric angle. Eccentric angle is called the eccentric angle. Now what is the tangent with this point? Tangent at any point S, we'll rewrite this as S equal to 0, is given by S1 equal to 0, that is x into a secant theta tangent at theta is given by x into a secant theta by a square minus y into b tan theta by b square minus 1 is equal to 0. That is S1 equal to 0. We use the tangent equation. So that makes it, that is x secant theta by a minus y tan theta by b is equal to, or minus 1 is equal to 0. Now what is the slope of this? Slope here, we can, what do we have as a slope? Minus of the coefficient of x by coefficient of y. So minus of secant theta by a into b by tan theta with a minus sign. So this minus and minus will become plus, and we have here b by a cosecant theta. So it's b by a cosecant theta. Now, so the slope of the tangent at any point theta to the hyperbola is b by a cosecant theta. This has to be borne in mind. Now, we are given that 4x minus 3y minus root 3 equal to 0 is the tangent. This is the tangent. At some point to the hyperbola, 4x square minus 9y square is equal to 1. This is the hyperbola. So we have this to be x square by 1 by 4. Let's write it in the standard form. Y square by 1 by 9 is equal to 1. What is this 1 by 4? That is our a square. And what is this 1 by 9? That is our b square. Okay. Now what do we have here? B by a cosecant theta should have been the slope of this. What is the slope of this? Slope of the tangent is 4 by 3. Now that has to be equated to b by a cosecant theta. What is b by a? 1 by 3 by 1 by 2. So that is 1 by 3 by 1 by 2 into cosecant theta. Cosecant theta. So that makes it 2 by 3. 4 by 3 is equal to 2 by 3 cosecant theta. So cosecant theta has to be 2 then. Cosecant theta is 2. So what should be the theta value? Theta has to be pi by 6. This implies theta has to be pi by 6. Therefore, the eccentric angle of the point at which this becomes the tangent to the hyperbola 4x square minus 9y square is equal to 1 is theta equals to pi by 6. Therefore, the right option is 2 is the right option. Option 2 is the right option. Okay, let's move to the next question, question number 18. The point of intersection of the two tangents to the hyperbola x square by a square minus y square by b square equal to 1. The product of whose slopes is c square is lies on the curve y square minus b square is equal to c square into x square plus a square. That's the first option. Second option, y square plus a square is equal to c square into x square minus b square. Third option, y square minus a square is equal to c square into x square plus b square. Fourth option, y square plus b square is equal to c square into x square minus a square. Now, we know that from an external point, say x1 comma y1, two tangents can be drawn. Two can be drawn to a hyperbola. Suppose you have a hyperbola. From some point x1 comma y1, we will be able to draw two tangents to the hyperbola. What is any equation of the tangent to a hyperbola? Y equal to mx plus under root over a square m square minus b square. Let's say that is the equation of the tangent. And that is passing through x1, y1. So, y1 is equal to mx1 plus root over a square m square minus b square. So, that is a tangent is there with slope m, and that is passing through x1, y1. So, I substituted the point x1, y1 in the tangent. Now, what we have is, we can frame a quadratic equation in m. y1 minus mx1 the whole square is equal to a square m square minus b square. Now, what do you have? M square into x1 square minus a square minus 2x1 y1 into m plus y1 square plus b square is equal to 0. y1 square plus b square is equal to 0 then. Now this is clearly a quadratic in M. How many roots can be there for it? At most 2. So since it will have 2 distinct roots, since the discriminant of this will be positive, that comes from the fact that x1 comma y1 lies outside the hyperbola. So this is going to yield 2 distinct real roots. Okay, right. Now what do we have? He has given that the product of the slopes, suppose m1 and m2 are the slopes, are roots of this, which will actually become the slopes of the 2 tangents. So m1 m2 are the roots. What is the product of the roots? m1 into m2 product of the roots is m1 into m2 is equal to the constant term by coefficient of m square. So what is that? y1 square plus b square by x1 square minus a square. So clearly he says that the product of the roots is c square. So c square is equal to y1 square plus b square by x1 square minus a square. So this point x1 comma y1, the locus of this point x1 comma y1, or the curve on which x1 comma y1 lies, will be given by, I replace x1 y1 by the general coordinate. So what do we have? Y square plus b square is equal to c square into x square minus a square. So x1 comma y1 lies on the curve y square plus b square is equal to c square into x square minus a square, and that is clearly appearing in the fourth option. Option 4 is the right answer. Let's move to the next question. The equations of the tangents to the hyperbola 3x square minus 4y square is equal to 12, which make equal intercepts on the axis are: first option x plus y is equal to plus r minus 1, second option x plus y is equal to 2, third option x plus y is equal to 3, fourth option x plus y is equal to 4. Now if a line makes equal intercepts with the axis, then its slope has to be either plus 1 or minus 1. See, for example, you have a line like this. This is a and this is also a. What is the slope of this? This is in the form of x by a plus y by a is equal to 1. Y by a is equal to 1, and therefore the slope of this is minus 1. You could have a line like this making equal intercepts here. This is minus a and a. The length is same. This minus a and this is a. So what would have been this line? This would have been minus x by a plus y by a is equal to 1. Y by a is equal to 1, and that makes it, this will be of the slope 1 here. So when a line is making equal intercepts with the x-axis or y-axis, its slope has to be either plus 1 or minus 1. Now we are interested in the tangents with slope plus 1 or minus 1 then. So m has to be plus 1 or minus 1. Okay. What is the hyperbola given to be? Let's standardize it. X square by 4 minus y square by 3 is equal to 1. We know that the tangent for it is given by y equal to mx plus or minus under root over a square m square minus b square for, this is the tangent for x square by a square minus y square by b square is equal to 1. Now instead of a square we have 4 and instead of b square we have 3. So what we, and instead of m what should I take? Plus or minus 1. So y is equal to plus or minus 1 into x plus or minus under root over a square m square. What is a square? 4. M is plus or minus 1. So m square will be 1 only. M square is 1. So 4 into 1 minus b square is 3. So that is 3. So what do we have? Y is equal to plus or minus x plus or minus 1. So that, now that, so if I take a minus sign here, I'll get x plus y. So I'll get x plus y to be equal to plus or minus 1. So taking a minus sign here, of course 4 possibilities are there, but looking at the options here, in the options we have all the lines with the negative slope there. So let's take a line with the negative slope. So x plus y is equal to +1 or -1. This is the right option. So option 1 is the right option. Let's move to the next question. Question number 20. The number of tangents drawn from the point 3, 0 to the hyperbola x square by 9 minus y square by 1 is equal to 1 is first option 0, second option 1, third option 2, fourth option 3. Now let's actually plot the hyperbola. X square by 9 minus y square by 1 is equal to 1. Okay, 3, 0 and minus 3, 0 are the vertices of this hyperbola. So clearly it's a point on the hyperbola. From a point on the hyperbola, we can only draw one tangent. So that tangent also is actually your line x equal to 3. So only one tangent can be drawn from the point 3, 0 to the hyperbola, because that happens to be a point on the hyperbola. So the option is only one tangent. So option 2 is the right answer. Well, let's move to the next question. Question number 21. A normal to the hyperbola x square by a square minus y square by b square equal to 1 meets the axis in capital M and capital N. The perpendiculars to the axis through M and N meet at a point P. Then the equation of the locus of the point P is. Options are: first option, b square x square minus a square y square is equal to a square minus b square the whole square. Second option, a square x square minus b square y square is equal to a square plus b square the whole square. Third option, 4 into a square x square minus b square y square is equal to a square plus b square the whole square. Fourth option, a square x square minus b square y square is equal to 4 into a square plus b square whole square. Now, for a hyperbola x square by a square minus y square by b square equal to 1, normal at x1 comma y1 is given by a square x by x1 minus b square y by y1 is equal to a square minus b square. Okay. Now this normal, no, I'm sorry, it's plus here. It is minus for in the context of ellipse, and it will be plus in the context of hyperbola. So for a hyperbola, the normal at a point x1 comma y1 is given by a square x by x1 plus b square y by y1 is equal to a square plus b square. He says that this normal is meeting the axis at capital M and capital N. So the x-intercept will be obtained at the point M and the y-intercept will be made at the point N. So this must have been some normal. It's meeting the axis at M and capital N. So how do I get this coordinates of M and N? I'll make this into the intercept form. What is that? X by a square plus b square into x1 by a square. And we can write this in the form of y by a square plus b square into y1 by b square equal to 1. I am just regrouping the terms here. Now he says from M and N perpendiculars are drawn. Let us say M is some alpha comma 0, N is 0 comma beta. The perpendiculars are drawn to the axis at M and N. Where do they meet? This point P is the point alpha comma beta. In our context, what is alpha? In this context, alpha happens to be a square plus b square into x1 by a square, and beta happens to be a square plus b square into y1 by b square. Now we are interested in the locus of this point alpha comma beta. Okay, but then what do we know about x1 and y1? x1 comma y1 is a point on the hyperbola. So we know that from here we can write the value of x1. What is that? x1 is equal to a square alpha by a square plus b square. A square alpha by a square b square. Now x1 square by a square would have been a power 4 alpha square by a square plus b square whole square. That is x1 square is this by a square. So a square cancels and you will have a square alpha square by a square plus b square whole square. Similarly, y1 square by b square would have been b square beta square divided by a square plus b square whole square. Similarly, because the same thing, okay, we have y1 square by b square to be equal to b square beta square by a square plus b square the whole square. Now what do you know about this hyperbola? I mean, this point x1 comma y1 happens to be a point on the hyperbola. So it satisfies the equation of the hyperbola x square by a square minus y square by b square is equal to 1. So x1 square by a square minus y1 square by b square must have been equal to 1. So what do we have here? We have here, okay, a square alpha square minus b square beta square divided by a square plus b square the whole square happens to be equal to 1. Okay, which actually gives us, we wanted the locus of alpha comma beta. We wanted the locus of alpha comma beta here. So what is alpha comma beta? Instead of alpha comma beta, I can replace it by x comma y. So what we have is a square x square minus b square y square is equal to a square plus b square the whole square. So that is the locus of the point alpha comma beta from, right, that is the point where the normals at m and n are meeting at P. That point, we wanted the locus of that point, we could rewrite. So locus is this. Locus is a square x square minus b square y square is equal to a square plus b square the whole square, and option 2 is the right option. Let's look at the next question. Question number 22. All chords of the curve 3x square minus y square minus 2x plus 4y equals to 0, which subtend a right angle at the origin, passes through a fixed point. Options are 2 comma minus 1, second option 1 comma 1, third option 2 comma 3, fourth option 1 comma minus 2. Now the curve is given to be 3x square minus y square minus 2x plus 4y equals to 0. Now there are some chords which subtend a right angle at origin. We are asked to show that all such chords which subtend right angle at origin, this is the origin, you may have many such chords which subtend right angle at origin, all these chords will pass through some fixed point. What is that fixed point? We have to find out. Okay, so what I do is, I will take that chord which subtends right angle to be Lx plus My equal to 1. Let Lx plus My equal to 1 be the chord, equation of the chord which subtends right angle at origin. Subtends right angle at origin then this pair of lines from origin to this points to these ends, passing through the ends of the chord, that is OA and OB, combined equation of this can be obtained by homogenizing the curve with the help of this line. So what do we mean by homogenization? All the terms have to be brought into a degree 2 term, because you have, that is what is homogeneity. So these two terms are of degree 2, these are of degree 1, so we can bring those terms also into degree 2. How do we do that? So 3x square homogenizing will have 3x square minus y square plus 4y minus 2x into 1, that 1 I will write it in the form of Lx plus My. 1, that 1 we can replace it with Lx plus My. So Lx plus My is equal to 0, here. Now this is the combined equation of OA and OB, where AB is the chord, Lx plus My is equal to 1. Now if these two lines are to be perpendicular, we know that the coefficient of x square plus coefficient of y square has to be 0 in this pair of lines. So coefficient of x square plus coefficient of y square must be equal to 0. That is the condition for a pair of lines to be perpendicular to each other. Right. So this is a second degree equation. It represents a pair of lines passing through origin. This lines OA and OB, they are given to be perpendicular. So coefficient of x square plus coefficient of y square is equal to 0. Let's club the coefficient of x square. What is the coefficient of x square? X square coefficient is 3 here and minus 2l here. So 3 minus 2l. Do we get x square coefficient in any other, x square term in any other way? No way. So 3 minus 2l plus, now let us club the y square terms. What do we have the y square coefficient here as? Minus 1. Now let us see if we have a y square term here. Yes, we do have. 4 into m minus 1 is equal to 0. The coefficient of y square here is minus 1. So coefficient of y square here is 4m. So 4m minus 1 is equal to 0. So that makes it minus 2l plus 4m plus 2 is equal to 0. I try to match it with Lx plus My equal to 1. So let's match it. So let's divide by minus 2. What do we get? L minus 2m minus 1 is equal to 0. I am dividing by minus 2. So what do we get? Divide by minus 2. From here we will get this step. This implies this. We observe that we can rewrite this in the form of L into 1 plus m into minus 2 is equal to, transpose this minus 1 the other side, m1. So now it has been matched with the given chord equation there, where we started with Lx plus My equal to 1. Instead of x we have 1 and instead of y we have minus 2. So this chord Lx plus My equal to 1, from this condition we can say that it will always pass through the point 1 comma minus 2. Therefore Lx plus My equal to 1 passes through 1 comma minus 2. What is that point? 1 comma. So all such chords which subtend a right angle at origin will satisfy this condition, and that condition we are reinterpreting it. We are trying to match it with this line equation, and we are able to find that the point through which this line passes is 1 comma minus 2. So the option 4 is the right option. Option 4 is the right option.